Hello everyone. Carlos Strauss is considered to be the first person who used the term NoSQL in 1998, but it was until the mid of 2000 that the NoSQL train really picks up. It started with Neo4j, and then CouchDB, MongoDB, Cassandra, to cite a few. But although the NoSQL systems are continuously growing in popularity, there is no standard way to write tests for applications that uses NoSQL engines as a backend. My name is Alex Soto. I'm a computer engineer. I work in an international pharmaceutical company developing in vitro devices. I'm also taught at Open University of Catalonia, and I belong to the DzOne MBB program. And today I'm going to introduce you NoSQLUnit to write tests for NoSQL applications. But first of all, let me start with some theory so we can understand the origin of the problem and why NoSQLUnit is important. Tests in general and unit tests in particular must follow the first rules. Your tests should be fast. If you are fast, you will run them more often. Your tests should be isolated. The execution of one test cannot condition the result of another test. Your test should be repeatable. Without any change, your test should always return the same result. Your test should be self-validated. You should treat your test code as the production code. And among other things, this implies that your test should be clean. Anyone with a quick overview to the test should understand exactly their purpose. And your test should be written timely. You should write first your tests and then the production code. There is but an exception with the high-level tests like integration test, acceptance test, or smoke tests, for example, where they can be slow. But the other four rules are still valid. So the most broken rule when writing tests for persistent layer is the isolated one. Let's see an example. Suppose we've got a code which saves a phone to the database, and then we've got two tests. One which tests the insertion method, and another one which counts the number of phones inserted into the database. So as you can see, depending on the order of the test, the count test will return one result or another one. To solve this problem for relational database management systems, we've got DbUnit, and for NoSQL systems, we've got NoSQLUnit. NoSQLUnit is a JUnit extension that aims us to manage the lifecycle of required NoSQL engines, also help us to maintain the databases into a known state, and finally, standardize the way we write tests for NoSQL applications. It's composed by two groups of JUnit rules and two annotations. Let's see in more focus. The first group starts and stops the NoSQL engine required for running the tests, and at least each supported engine will implement one of this kind of group. The other group can be understood as a connection to the database under test, and this rule is used for maintaining the database into the known state. Then we've got the first annotation called using dataset, which is used for seeding the content of a dataset file into the database under test. And this annotation is an optional annotation. It's called should-match dataset, which is used for comparing the database contents against a database file. So let's explore the workflow of NoSQLUnit. Typically, you will use NoSQLUnit for, first of all, starting the engine. Then the database is clean. Then the database is populated with known data. The tests are executed. Then comes the optional step, which verifies the content of the database. And finally, NoSQLUnit stops the server. Notice that depending on your test configuration, the start and the stop method steps are only executed the first time, and the other steps are executed for each test run. So, well, let's see NoSQLUnit in action. Actually, NoSQLUnit supports these 5 engines, which, according with Indeed.com, are the most popular. Who of you are using one of these engines? Well, that's okay. Then let's start with the first engine. It's Redis. For Redis, we've got 2 rules to manage the lifecycle. The first one creates an embedded in-memory Redis. Note that because there is no Java implementation of Redis systems, NoSQLUnit provides one implementation for you, which is based in Redis API. The other one is the managed Redis, which starts the Redis server from its installation directory. To establish the connection to the Redis, it's used the Redis rule, and the dataset file format is a JSON file, where you define the datasets of Redis. This is a sample, a list, source set, hash, or set, and then you define the keys and the list of values belonging to that key. Let's see a demo. In this case, we're going to write a unit test of a very simple application which cache the last tweets of a user. I've got here the project. First of all, we're going to install NoSQLUnit. It's only a dependency. Here we can add. We choose the Redis one. Then here is the test. The first thing to do is starting the embedded Redis, because we are writing a unit test. And NoSQLUnit provides a static factory method to be more easy to create these rules. The next thing to do is establishing the connection to this embedded instance. Again, we've got a static factory method. And we're going to use the default method, which returns a Redis rule configured for the default parameters. And then we're going to write here the annotation to inject all the known data into the database. In this case, see that we've got 2 users, Gollum and Frodo, and the Gollum always say, "my precious." So we're going to test the tweets of Gollum. Note that here we're asserting the "my precious" tweet. So we are using here the annotation where we set the location of that JSON file. And finally, we can define the load strategy to follow. That in this case, we're going to use the clean and insert one. So now we can run this test, and obviously passes. passes. The next one is Cassandra. In this case, we have two rules for manage the lifecycle. The first one started an embedded Cassandra, which in fact internally uses the Cassandra daemon class provided by the Cassandra jar, and the managed one which start Cassandra from installation directory. To establish a connection to the key space used is the Cassandra rule. And the file is a JSON file again, where you can set the key space, all the column families, if they are separate column or not, well, the keys, all the values, etc. The next one is HBase. For HBase, we've got, again, two rules for managing the lifecycle. The first one is an embedded HBase, which internally use the HBase testing utility class that is provided by the HBase test jar, and the managed one, which obviously start an HBase instance from its installation directory. To establish a connection to the table name, we use HBase rule. And again, the file is very, very similar to the Cassandra ones, but note that it's more simple because HBase, for example, does not support separate columns. The next one is Neo4j, and in this case it's a special case because we've got 4 rules to manage the lifecycle of Neo4j. The first one starts an embedded in-memory Neo4j. The next one is starts an embedded Neo4j. Then we've got the managed wrapped Neo4j. This is an embedded Neo4j wrapped by a layer of sockets, so you can access a Neo4j instance externally, and the managed way which starts Neo4j from the installation directory. To establish the connection to the Neo4j is the Neo4j rule. And in this case, the dataset file format is an XML, which follows the GraphML specification, where, as you can see, it's very easy to follow. You define the keys, and then you can define all the nodes and the edges and the relationship between them. So now we are going to write an integration test of a Neo4j application that, in fact, is the typical Neos Friends application. We want to write 2 tests, one which counts the number of the friends of Neos, and the other one which add a new friend to the graph of Neo. So I've got a Neo server installed in this directory that I'm going to copy. And again, we can, in this case, we must provide the Neos path, installation path. I don't know if it cannot be seen. Wait. Now, then we create the Neo4j rule. And again, we can use the default managed Neo4j method because it returns a Neo4j configured for using the local host, the default Neo4j port, or the default database. And then you can see here the XML with all the friends of Thomas Anderson. So again, we use the same annotation. And now let's run the test. Note that it's a bit slowly because I have to start the Neo4j server. Okay, note here where NoSQLUnit are notifying us that he is starting a Neo4j instance. The other test is the addition one, which it's configured in the same way, but here we're going to use the should match data set, where the data set is expected metrics.xml. This is a wrapped server to make it more fast. And note that the test fails, and that's because the expected file is wrong. If you see the test, I've added the Oracle as a friend of Neo, and here there is no Oracle. So we put here Oracle. And then if we run the test, it passes. And now the last one is MongoDB. Again, we've got two rules for managing the lifecycle. The first one is an embedded in memory MongoDB, which internally uses a project called gmagmongo. It's an external project, nothing related with NoSQLUnit, which is a Java implementation of MongoDB. And then the managed one, we just start the MongoDB from the installation directory. To establish the connection, we use the MongoDB rule. And again, now the dataset file format is a JSON file. And it's as easy as you define the collection, and then inside this list, you put all the JSON documents you want to goes into that collection. But apart from providing support for engines, NoSQLUnit provides more capabilities. For example, NoSQLUnit is ready for the cloud. In cloud computing, you don't have to manage the database lifecycle. It's managed by an external entity. So it's a simple matter of establishing a connection to that remote server. And we're going to see this. In this case, we're going to write an acceptance test with 2 CDDs and with an application deployed in OpenShift, which is a very, very simple library which returns all the books available for the users. Here is the application deployed on OpenShift, and if you see, this is the MongoDB, which have no collection. And if we go to the application, there is no book into the MongoDB. So let's write an acceptance test. In this case, we're going to use this JSON file, which inserts 2 books to the MongoDB database. In this case, the collection is called book, and we add 2 books, The Lord of the Rings and The Hobbit. And so this is my story file. Note that you can use any runner you wanted. For example, in this case, we are using 2 CDs runner, but you can use a Spring runner, big or category runner, because NoSQLUnit is based on rules. So we're going to configure this. In this case, there is no default configuration possible because you have to set all the parameters. So we're going to set here, we need to put the database name. Then the host. Note that I'm setting the local host address because I'm using a capability of OpenShift, which you can set a port forwarding. So when you are accessing the local host, you're really accessing the external server. And then the username. Okay, note that there is no lifecycle management rule. And then I enable the port forwarding. So here you are mapping the local host to the remote host. And then we can run the test. You have to see the same page as I have shown you with no bugs, but now you will see 2 bugs. I'm not a UI designer, but well. And if you don't believe that a NoSQLUnit have connected to the remote database, we can go here to Rock Mongo. And then we've got inserted both books. But NoSQLUnit also supports the polyglot persistence approach. Your NoSQL applications can use more than one engine. For example, can use Redis for caching and MongoDB for storing the data. And NoSQLUnit also can deal with this problem. In this example, I have defined 2 connections, and I have given them a name. One name for Neo4j, another one for Redis. Then, using selective annotation and this given name, we select which data set goes for each connection. So in this case, Neo4j uses the metrics XML, and Redis uses the metrics.json. But it's even more. Sometimes when running your test, you will require access to the underlying object using in the connection rule. To solve this problem, NoSQLUnit provides a partial support for GSR 330, so you can use the inject and the name it annotation. See, for example, here I'm defining a connection to the MongoDB, and using the inject annotation, I'm setting the Mongo class used inside MongoDB, so you as test writers can use it freely. In fact, I have already used this. If you look the first example, see here, I am setting the Redis instance used inside the Redis rule to the test. So can be passed as a parameter to the constructor of the business object. But also have support for Spring data, because it's a simple matter of knowing how Spring data maps the objects to the database. So your dataset files should be follow these rules. And also for Hibernate MongoDB, which is a simple matter of mapping the property names with the document names. This is what is implemented in NoSQLUnit, and now I'm going to show you what is going to be implemented. Every 9 months appear a new NoSQL vendor, so it's impossible to stay updated all the time. In the next months, I will implement support for Google's big tables, CouchDB, DEX, InfiniSpan, and Memcache. But also, I will give support for Darkilian, for Amcrest, for Maven, so you can start and stop your engines within the Maven lifecycle. And because NoSQLUnit means not only SQL, it's like your application still needs SQL systems, I will provide integration with DbUnit. But of course, this can change because I give a high priority to the issues opened by the NoSQL users. So if you have any other preferences, like for example, I want you provide support for any other engine, you can open an issue and I will try to implement as fast as possible. And well, writing persistent layer tests is a very hard and tedious job. You know, you've got a lot of dataset files, some of them with a huge amount of data. You have to write all of them, and you know, you have a lot of files dispersed for all your project. But I think that it's necessary to write testing persistence layer test and try to avoid this conversation. Here you can see the Spider-Man boss who said to Spider-Man, if we can stop writing tests, because we will implement the production code more faster. And then Spider-Man said, well, yes, we can stop it. And maybe they will notice at first, but this will ruin our internal quality. No? And see the answer of the Spider-Man boss. So please try to avoid that the testing persistent layer test ruin your internal quality. I would like to say thank you very much for the DevOps folks for allowing me to stay here, and also thank you very much for coming to my presentation. If you had any questions, or you can send me an email, a Twitter, you come here if you want to ask me anything. I have personal cards. Well, thank you.